Greetings, Calc 2 students. This video is for section 10.1, Parametric Equations. And one of the things we're often asked to do is to convert from a Cartesian to a parametric equation. So remember that in general, a Cartesian equation is often a function of x. So we have y of x equals a rule, and that rule is a function of x. And we want to convert that from that Cartesian form to a parametric form. And so we want x of t to be a function of t, and y of t, the easiest way to do that is just make that t. So for example, I have this equation, y of x equals 7x cubed minus 4x plus 9, and I want to parameterize that. Well, all I would need to do then is say that x of t is equal to 7t cubed minus 4t plus 9, and y of t is equal to t, and then choose a starting point and ending point. So let's say negative 10 to 10. Choose some a and b. And I have now parameterized that Cartesian function into a parametric form or a parametric equation. So that is a simple way that we can always convert Cartesian into parametric. Now, often though, we're going to be asked to convert from parametric to Cartesian. This is not always easy. Sometimes it's extremely difficult. So the idea that we're going to do is eliminate the parameter in the cases that are a little easier to handle. So example number 1, I have this parametric equation, x equals 3t plus 2, and y equals 2t plus 3, and I want to convert that from its parametric form to a Cartesian form. So the thing that I always remember is I am trying to eliminate the parameter, so I'm getting rid of the t. That's the thing I want out. But I remember that I want things to be y as a function of x. So I'm going to take the x thing, solve it for t, and then plug that in for t. And I'll be left with y as a function of x. What I'm going to do is take x equals 3t plus 2 and solve that for t. So I have x minus 2, the whole thing divided by 3, that's equal to t. Then I'm going to plug that t, this t, in for the y side. And when I do that, I get y of x equals, and then I'll have 2 times t, but t is equal to x minus 2 divided by 3, and then plus 3. So all I did, again, was substitute this value that I solved for t in the x equation, and I plugged that into t, so 2t and then plus 3. So now I have converted to our Cartesian equation. And I could simplify that, I could expand it, but I have done the job of converting it. Let's look at another example. Another way that we can eliminate the parameter is by remembering this situation where we have cosine squared of theta plus sine squared of theta is equal to 1. So the Pythagorean identity, sine squared of theta plus cosine squared of theta is equal to 1. So if I look at my x is equal to 1/2 times cosine of theta, and I solve that for cosine of theta, I get 2 times x is equal to cosine of theta. So all I did was take this equation and solve it for cosine of theta, multiplied both sides by 2. And I do the same idea to the y, so y equals 2 times sine of theta. That implies that y divided by 2 is equal to sine of theta. So then, using Pythagoras' identity, I have cosine squared of theta plus sine squared of theta equals Well, cosine of theta is the same as 2x. So 2x squared. And sine of theta is equal to y divided by 2. So y divided by 2 squared. And cosine squared of theta plus sine squared of theta is equal to 1. So now I have 2x quantity squared plus y over 2, that quantity squared, is equal to 1. And so I have now converted from a parametric equation to a Cartesian equation.